Okay, first thing I would do is not find the derivative. I would rewrite this. 8x to the negative 2. Then I'll find its derivative. Keep the 8 out. Power, base, 1 less power. That's a negative 16 over x to the third. We want it at what x value? 2. So I'm going to put in a 2 in place of the x. And that's to the third power, I believe, here on the bottom. So there's negative 16 over 2 to the third. Negative 16 over 8. Negative 2 should be the derivative at that value. For 35, first thing I'm going to do is find the derivative, and I'm going to indicate it by f prime of theta. 4 is a constant factor. The derivative of sine is cosine. The derivative of theta with respect to theta would be 1. Just think of it like an x or a variable. So you have 4 cosine minus 1. What is the theta value that you want? Usually it's r theta, but either way the theta would be 0. Cosine of 0 is 1. Multiply before you subtract, and hopefully this should be the answer, 3. Okay, for 95 I'm going to use this formula. This is a projectile motion formula. And they're using s. My s's look like 5, so I'm going to use an x of t. Because it says it's a 1,362-foot tall building, it's in terms of feet. So g would be negative 32. 1/2 times negative 32 makes this a negative 16 t squared. That's because it's in terms of feet. If it would be negative 4.9 if it was in terms of meters. Plus v sub o. So plus v sub o times t. V sub o is the initial velocity. If you throw an object upward, you give it a positive initial velocity. Throw it downwards, it's negative initial velocity. This one says you drop this, so the initial velocity would be 0. Because you're on top of a building that's 1,362 feet tall, that's the initial height. So this gives me the position function, negative 16t squared plus 1362. Now that might be one of the things they ask. No. They want that is determine s of t, which I'm calling x, so this is a position function. And they also want the velocity. To go from position to velocity, you simply take the derivative. So 2 times negative 16 would be negative 32. So now I should have both the position and the velocity function. So that is your answer for A. Okay, they also want us to find the average velocity on a time interval from 1 second to 2 seconds. Average velocity is the change in position over the change in time. Change in time is easy, 2 seconds, 1 minus 1 second. The change in position would be the position at time 2 minus the position at time 1. So we'll figure these out right now. Here is the position function. X of t equals negative 16t squared plus 1362. First you're going to replace in the 2 to find x of 2. 2 squared is 4. 4 times negative 16 is negative 64. When you add those, I believe you get 1298. So 1298. And on bottom, obviously, is 1 for the average velocity. Now, I also need to put in a 1. So what would I get if I put in a 1 instead of a 2 here? You would have negative 16 plus 1362, which is 13 what? 1346. And when you subtract these, what do we end up with? Negative, what is it, 48? And because it's a velocity, that's going to be in feet per second. Now that's the average velocity on that time. And that would be your answer for part B. C wants the instantaneous velocity. C wants the instantaneous velocity at the time 1 and at the time 2. If you put a 1 into your velocity function, you'd get negative 32 times 1, which is negative 32. And again, velocity is going to be in feet per second. If you were to put a 2 into here, you'd get a negative 64. You may notice that the average velocity is right in the middle between the two instantaneous velocities. So there's your A, B, and C. D says find the time required for the coin to reach the ground and the velocity of the coin at impact. If I remember, our position was negative 16t squared plus 1362. Is that right? 1362. And x of t is the height above the ground at time t. I want to know the time it takes to hit the ground. When it hits the ground, the height above the ground is 0. So I would move the 16t squared over, divide by 16, and take the square root. 1362 divided by 16. Okay, hopefully we end up with about 9.226 seconds. So you get about 9.226 seconds. That's the time it takes for it to hit the ground. They also ask with what velocity it hits the ground. You'd have to use your velocity formula and put in the time that we have, which would be 9.226. And when I do this, I get the velocity at the time of impact. 9.226 is going to be 32 times that number, negative 295.242. If you are accurate, and again that would be in feet per second. I used a stack operation on my calculator so I did not lose accuracy, but this was part D, right? The time it took to hit the ground and the velocity at which it hit the ground. The sad part about this problem is this is a problem that refers to the World Trade Center. The old World Trade Center was 1,362 feet tall, and anything that fell or dropped from the top of it would have impacted the ground at this velocity and would have fallen for 9.226 seconds.